Video is going to be part two for week 11, which is going to just be a quick overview and review of the PowerPoint slides we covered last week, just to get ourselves in the headspace of continuing and building on the blocks that we sort of laid for foundation last week on pointers and references. So we kind of talked about what pointers and references were. So starting with a reference, remember, it's just that alias of a variable and it stores a location in memory. So when you use the reference, you're actually using the variable it refers to. And if we put the symbol in front of it, then we'll just get the actual value of that reference variable, which is the address that it stores in memory. So to use a reference in a loop, what we can do is actually, in this example, we're trying to change the copy of str to funny, remember? And so when we print it out, it doesn't actually change the names Larry, Moe, and Curly to funny, funny, funny. But if we use a reference, which is using that ampersand key character, then when we do str equals funny and we assign that string to str, when we print it back out to the user, we get funny, funny, funny instead of Larry, Moe, Curly. So actually using and changing the reference changes the original value's location. All right. Another example of using a reference in a loop here. Now, if you make it a const, so when you just want to use a reference variable to print or view data, but you don't want to change it or assign something new. So here, when we try to assign something new, obviously you get an error because we made it a const. All right, and here, this is fine because we're just outing str to the user, so making it a const actually makes sense. So we covered this example in CodeLite, and you can type this out and test it yourselves. And then we kind of talked about what a pointer was. So a pointer and how it's different from a reference variable. So basically a pointer, same thing. It's a variable which value its value is an address. And things that can be at that address is another variable or a function. And the main difference between pointers and references is once you set a reference to refer to something, you can't change it. You can't update it. That's it. That's what that reference is, and it's set in stone. With a pointer, we can update pointers, pointer names, all of that stuff, and it's very dynamic and it's a lot more powerful. It allows us to have a lot more options with what we're doing. So that's why you'll see a lot more of these slides are focusing on pointers because there's so much more we can cover and implement with pointers in our code. So same thing, it stores an address, and if x was an int variable and it had a value of 10, I can make a pointer that points to that int, right? So to be able to use the data that that pointer is pointing to, remember we have to do something called dereferencing, and I'll show you what that looks like again. So why do we want to use pointers? Well, a couple of reasons why we want to use pointers is scope. So we can't actually access the data from outside of the function we're in if we're going to, then yes, pointer to something because we can't pass in the variable that we want to, maybe. Pointers also can be used to operate on arrays really, really efficiently. So we talked a little bit about the relationship between arrays and pointers and how array names are also just an address in memory. And so if we get a pointer to that array name, it's the same address in memory. So, using pointers and arrays, we can, work way more efficiently. Also, we use pointers to dynamically allocate memory on that heap, that free store that we were talking about in the first video there, which is able to change the size of how much memory we need in our program at runtime during the running of that program. Okay? And the only way to actually get memory that we've allocated on the heap is through a pointer. There's no other way. You can't save it to a variable. You can't save, whatever and reference it from your program into the heap. You have to use a pointer. So pointers are also how polymorphism works, which is what we'll talk about, in the future in a couple of weeks with object-oriented programming. And if with C++ specifically, we usually develop things like drivers, embedded systems, system applications, and it's really useful to be able to have pointers that reference to things like your registry keys and addresses in memory. So that's why pointers are really important. So how do you declare them? Remember, we use the asterisk key symbol or character in front of, and you can put it on either the type of pointer you want to point to, or you can put it on the pointer name. Doesn't matter. And remember, we always want to initialize our pointers. So here we're initializing it to nowhere, to point to nowhere, or 0, null pointer. Do this if you don't know what you want to point it to and you just want to initialize, not initialize, which is the wrong syntax. You'll point, it'll just fill it with some garbage data and it will actually be pointing somewhere on your machine, but you don't know what you're messing with. So you could actually be changing some really important, data down in your drivers, and you don't want to be touching that stuff. Okay, so we initialize it to 0. That's something C++11 gave us. And to actually access our pointers, we use the address operator, so the ampersand, right? So if we actually want to get the address of the pointer, then we do the address and then say num here to get that address operator. So accessing the pointer address, you just put the address operator in front of your pointer name. So here our pointer name is p. It points to an int variable. The value of p is garbage data because we haven't initialized it. The address of p is going to be the actual address of the pointer itself, not the address of what the pointer is pointing to. I know that's confusing. So imagine that image I gave you of a post box that has 10 different post boxes on it, or 10 different little mail slots for post mail, right? The post box points to 10 different houses. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And houses 1 through 10 on the street will come to that pointer to collect their mail. So house 1 might be 1 Beckett Drive, but the post box that they have to collect their mail from has its own address as well, which might be 30 Beckett Drive. Now, in this example, when the pointing to, so 1 Beckett Drive for the house, but when we print the address of P, so the address of the postal box itself, we're going to get the address of the pointer, where the pointer is stored in memory, which would be 30 Beckett Drive, right? So, and then we use the size of, to get the size of our pointer. On your machine, it might be different. Cool. Let's see, what else do we do? To store an address in a pointer variable. So here we made an int called score and initialized the value to 10. And then we initialized our score pointer here, that's a type int, to a null pointer. And then when you want to save the address of an int variable that you have somewhere in it, you need to use that reference operator, the ampersand symbol, in front of your variable that you want to store in the pointer. So now this pointer will point to the address in memory where the score variable is stored. Cool? All right. And remember, you can only point to the types of pointers, to types of variables that your pointer is set to point to. So here's a pointer that points to ints. I can't point it to high temp because high temp is a double. I can only point it to score, which is an int. That's why we get a compiler error. I'm going to make sure I turn on my cursor highlighter here so that it's easy for you guys to see my mouse. Just give me 1 second to do that. Just got to double click this. There we go. All right. Moving on. I know we're going fast. This is just a review. You can also watch last week's video if this is going too fast for you. So we did an example in Code Light. And now we talk about dereferencing a pointer. Just accessing the data that we're pointing to. So instead of printing the address of 30 Beckett Drive, okay, then we actually get the value of what's at 30 Beckett Drive. So, it could be an int that has the value of 10. Then we can actually print out 10, not just the address of where 10 is stored, right? So here I've got an int score of 100, and I created an int pointer that's going to point to the address of score. Now, if I dereference the pointer using the asterisk keyword, or sorry, key symbol, then I'm going to get the actual value of what that pointer is pointing to. All right, if I don't put that asterisk there, then it's going to print out a hex variable, which is the address of where score lives in memory. Okay. Then we can also use the dereference character to assign a new value, and it will actually update both the pointer because it's pointing to and the variable because they're both the same object. They're pointing to, the same address in memory. So when we update the value at 1, we're actually updating the value for both because they're the same thing. All right? So we use that asterisk key symbol to dereference an operator. You only use the asterisk when you are initializing a pointer, okay? Right here. And you have the variable type. Every time after you use the asterisk, it'd be dereferencing it. Okay, so it's easy to remember it that way. Okay, so here we have a string named Frank. Okay, the variable is name. Then we create a pointer that points to a string type, and we set it to the address using that address operator to the variable name, so the address of name. So now, then when we see out, but we use the dereference symbol, the asterisk, we're going to get the address's value, okay, because we have that. So then we print out Frank. Then we can set name equal to James, so our variable. And then if we print out the dereferenced pointer again, then we actually see it updated because when we set the value of name, since the pointer is pointing to the address of name and they're the same thing, it updates it for both the pointer and the variable because they're the same thing. Cool. So now talking about dynamic memory allocation, basically this is allocating storage from the heap at runtime. Okay, so we talked about the heap at the very beginning of class today, and if we don't know how much storage we need until we need it, we can actually allocate it into a variable or into an array at runtime while the program is running. We can get a variable from the user and create a certain amount of arrays or whatever, ints, and we don't know how many we need until we need them. It's very helpful. So we can shrink or grow what we need. So dynamic memory allocation, remember we use the new keyword to allocate storage. So here I've got a pointer, it points to the type int, and I've initialized it to null. Then I set my pointer equal to a new int. And what this does is it creates an int variable, but it doesn't create the int variable on my stack, right? It creates the int variable on the heap. So going back to kind of what we were talking about this morning with heap storage versus stack storage, if this is my stack down here, okay, and say I have a local variable of num1, okay, and then I do this bit of code, this is the heap up here. Well, what that's going to do is that's going to create an int up here, and it's going to call it, well, it doesn't actually have a name because there's no variables on the heap. Or I shouldn't say variables. There's no way to get what we have on the heap without a pointer. So I've created a pointer here too, right, in my local memory. So I also would have int underscore ptr, which is this variable, okay? And that's going to go down here, okay? And it is set to the address or the hex value of my int up on the heap. So it's going to point up to here, to this. Now I can set this value to whatever. So here I set it to 100. So this is 100, right? when we first print it out, we get the address, and that address would be, down here, 0 by 2, 7, whatever. And then when I dereference it, we're going to get garbage data because this int was set to nothing. But then once I set it to 100, this is set to 100. So the interesting thing here is this is an int and its value is 100, but you'll notice there's no name. There's no variable. It's not like it's int num2, right? It's on the heap. On the heap. So if we delete this pointer down here somehow, or we set it to null pointer accidentally, then oops, we just lost our only connection to get this value off of the heap. And there's no way to get it back because we don't know anymore what this address is. We lost it. Now, if you wrote this down somewhere or you printed it earlier in your program, then yeah, you would know that this is the address in memory for that variable. But if you don't have that, then you're done. So just kind of important to remember that stuff. That's what dynamic memory allocation is, and we use the new keyword to do that. So remember, we also have to deallocate our storage. So when we're done with something, then we have to use the delete keyword, and then that deletes it. It wipes it off of the heap, and then it deletes any of the records going to that address in memory, and then we don't have a memory leak. Okay, so it frees all that allocated storage back up to the machine for whatever system operations it needs it for. Okay. Continuing on, here we set an array pointer. So our name is array pointer, and it's set to point to an int. And we ask the user how big they want the array. We get that back in the variable size, and then we create a new int, and then we use these square brackets, obviously indicating an array, and then we pass the size variable in there, and it allocates an array of that many elements on the heap because we use the new keyword and new pointer, right? So now we can access that array from the heap through this pointer. Now, pointers and arrays, remember there's the relationship between them, so you can actually access them in a very cool way. And there's this example in CodeLight, and here is that drawing of the heap and then the stack code as well from earlier. All right, so this is kind of what I drew diagram of earlier with, something on the heap, and then you have a pointer pointing to it. If you delete that reference from the pointer by doing, pointer equals null pointer, then you delete that connection to that address in memory. Okay, so then this is what a memory leak looks like. So here we have a forever loop, while true, set the pointer to make a new array. So we just keep creating new arrays. And then it just says bad allocation, dynamic memory.exe has stopped working. So the relationship between arrays and pointers, we talked about this a little bit. Remember, when you print out an array name, it just prints out a hex value, which is the first element in memory, the address, of the first element in that array. So the value of a pointer's variable is also an address. So the similar thing between arrays and pointers is if we print out the name of an array and then we point to an array, that hex value or that address for both the array and the pointer is going to be the exact same address because they're pointing to the same address in memory. So the relationship between them means that we can use the same type of notation, subscript notation or array notation, however you want to call it, to access the values at them. So here we printed out the scores array and we get that address in memory, the hex value. Here we can use the dereference operator on an array, which is kind of cool because remember we can only dereference pointers, but because scores is an address in memory, we can use the dereference and then we can get one. Create a pointer array, and because the scores array is a type int and we make our pointer to type int, when we print out score pointer we get the same address, and when we dereference our pointer we get the same value, which is the first value or first element in the array. So you can use the same syntax on arrays as you can on pointers. Very important to remember, even if you don't use it all the time. So here we have a pointer that points to an int array of scores, and we can use array syntax on our pointer to get the different elements. Cool. Very, very cool. We can also use offset notation, which is doing +1 instead of using the square brackets with the 0 element or the 0 index. You can just do +1, +2, because remember, an array is the first address in memory, and then if you add 1 or 4 bytes or whatever size increment you have of the array, right? If your int is 4 bytes on your machine, then they just add 4 bytes. You can see here at the end, 0x61ff1 is the identical beginning in all three of them, but then you have 0, 4, and 8. So it just increments by the size of byte of whatever element is in that array. Subscript and offset notation equivalents. So basically, you can use subscript or offset notation in both arrays and pointers. Just kind of handy to know, whatever your preference is. And then we did an example in CodeLite, printing out arrays, and I have that code today. I can upload it to Blackboard for your reference. But that will be the conclusion or the review from last week. That's the Coles Notes version. I whipped through it, 38 slides. Hopefully that kind of, triggered some memory, from what we covered last week. I know it's been a little bit and a little while, so you probably forgot some stuff. So hopefully that was helpful. I'm going to end this recording here so it's shorter. And for the students that are asynchronous, they can watch this. And then we'll start our actual new material right